All right, the Unit 3 twin, polynomials, lots of factoring stuff too. And that's how it starts off, factoring. Right, two polynomials equivalent to 9x squared minus 36. Now, I look at this and I see this pattern right here. I see the difference of two squares pattern. It takes a 3x that is squared to become 9x squared. So I know that a is 3x. And it takes a 6 squared to become 36. So I know that b is 6. So I just plug into my little pattern, and I get 3x minus 6, and I get 3x plus 6. Now it talks about writing 2. And there's lots of ways to get the other one. One thing you can do is you can realize that both pieces have a 3. And then you can do 3 times 3, which is 9. Or from the get-go, you could have realized that both pieces have a 9, and then factored x squared minus 4. There's actually 3 different things that you could have been. These are all valid choices. Sorry, that one. Those are valid choices. There was actually 3 possible things. All right, express 12 cubed plus 6 cubed using a cubed plus b cubed, which is given as a plus b times a squared minus ab plus b squared. And there will be a lesser point version with hints, but if you are projected to test level 3, you better memorize your stuff, because I'm not giving it to you. So I know that a is 12 because I have a 12 cubed, and b is 6, and I'm just going to plug into my pattern. It's going to be 12 plus 6. This is going to be a 12 squared, minus, because there's a minus, 12 times 6 plus 6 squared. And it's really that easy. It really is that easy. All right, write 3 polynomials equivalent to 8x cubed minus 216 using this pattern. So a is 2x because 2x cubed is 8x cubed. And b is 6 because 6 cubed is 216 because we memorize things. So b is 216. It says write 3 things equivalent. That's crazy. 3 things equivalent. I don't know why I wrote 216. b is 6. Okay, so let's see what happens. We have 2x minus 6 because I'm following this pattern right here. Then I'm supposed to take all of 2x and square it, plus, because there's a plus, 2x times a 6 plus a 6 that's squared. Now, I would clean that. I'm pretty sure this would get cleaned up. I don't see me leaving this. 4x squared plus 12x plus 36. That's one of them. But there's a lot more that can go on here. I noticed that I can pull numbers. This will never have real solutions, and it really doesn't factor per se, but sometimes you can pull numbers out of it. But I could pull a 2, and I'd have x minus 3, and I could pull a 4, and I'd have x squared plus 3x plus 9, and then 2 times 4 is 8. So here's another one. Now, I could have gotten at that answer quite a bit quicker if I would have pulled that 8 from the get-go. I'm sure 8 enters 216. A little slow here, sorry. 27 times. This, by the way, is valid. It really is. And you can factor it. Here you'd have a is x and b is 3 because x cubed, 3 cubed, 27. And you would get this guy right here, x minus 3, x squared, plus 3 times x, or x3, but 3x, and then plus 3 squared, which is 9. So you look at that guy, and that guy. There's your 3 equivalencies. All right, 1 through 3 is done. Moving forward, write 2 polynomials equivalent to this thing. So this is probably a factoring by grouping. That's kind of the deal. If we see four terms, factoring by grouping, and by the way, quit blindly copying. Just stop it. You know who you are. Quit it. It's not doing you a lick of good. So what you need to do is you need to focus on the first two and the last two separately to some degree. And notice that they each contain, at least when I'm looking at the first pair, an x squared. So I can pull that x squared. If I pull x squared from x to the fourth, I have x squared. If I pull it from negative 16x squared, I have negative 16. And what did both of these pairs contain? Well, they both contain a negative and a 4. And the reason I have to pull that negative is because I need to turn that positive 64 into a negative 16. And, you know, you're supposed to know that 4 times 16 is 64. I can't fix your lack of math. All right, so moving forward, the common factor was x squared minus 16, and the stuff left over is x squared minus 4. There is an equivalent polynomial. Now, I maybe only a person factors a little bit of it. This factors is x minus 4 times x plus 4. And then you have x squared minus 4 again. That's an equivalent one. But there's more factoring. X minus 4 will, x squared minus 4, this guy right here, will factor as x minus 2. Getting ahead of myself. I'm talking and writing. This piece right here will factor as x minus 2 and x plus 2. There's a complete factorization. See, there's 3 different ways they're equivalent. Actually 4 if you include the first one. Use the remainder theorem to determine which of the following are factors of f of x equals x cubed minus 8x squared plus 11x plus 20. I don't know where the choices are. So let me pause this real quick and create some choices. So give me just a moment. All right, sorry about that. For some reason, I forgot to copy those in. So let's talk about these things. Usually when we talk about remainder theorem, we usually think synthetic division. And that's mostly me because I push synthetic division as opposed to plugging in a number. But I don't know if you remember this or not, but the remainder from division is equivalent to just plugging the number in. That's a big deal. So let's think about what our x values are first. This one says x is negative 2. This is kind of like zero product property. This one says x is a half. This one says x is 4. This one says x is negative 4. This one says x is 5. And this says x is 5/2. So if I want to know if these things are zeros or not, or factors, I can literally just plug them in. So let's find f of a negative 2. And if you're doing this by hand, I mean, it takes some time. You'd think negative 2 cubed minus 8 times a negative 2 squared plus 11 times a negative 2 plus a 20. And it would take you quite a bit of time to just sit there and constantly, even on a calculator, you'd be wasting time. Of course, there's lots and lots of ways of doing this, but I feel like teaching the storage feature here. So I'm going to take a negative 2, I'm going to store it to x, and play along. Maybe you'll remember the storage feature. I'm going to type in the equation as it's given up here. Notice I'm not wrapping and putting a 2 in. It saves sign mistakes. There's other things you can do too, like you can look at a table, but the table won't show you the fractions. So I got a remainder of negative 42. Which is not a 0. Therefore, x plus 2, not a factor. I'm looking for zeros. So I'm going to go through now, and I'm going to plug in the other choices. I can take the 1/2. I can store it to x, press enter. Then I can arrow up to the equation that I wrote, or expression that I wrote. Not a 0. All right, try again. Take a 4, store it to x. Arrow up, enter, enter, winner, winner, chicken dinner. This guy had a remainder of 0. This is going to be multiple select, by the way, so let's try the -4. -4, store to x. Arrow up, enter, enter, no. 5, store x. Arrow up, enter, enter. There we go, another winner. And let's check the other one, the positive 5/2. So 5/2, store to x, enter. And again, you need to be playing along. Dalton? No. So none of these worked because they didn't have remainders of 0. There was just those two. There's a third one out there. Who knows what it is? One of them might happen twice. That might be the problem. All right, using synthetic division or remainder theorem for that matter, determine if x minus 2 is a factor. State why or why not. And I could just plug a number in, but, synthetic division's where it's at. So if that's my factor, x is 2. Remember, it's always the x value that goes out in front. So it's 2. Sometimes you change signs, sometimes you don't. Notice it's missing no x. We need that placeholder. And our acronym was DMA. So we drop the 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. 0 plus 6 is 6. 2 times 6 is 12. -6 and 12 makes 6. And this is my remainder. This is my quotient. Okay, my quotient is x squared plus 3x plus 6 plus 6 pieces, because I'm talking about my remainder now, of x minus 2. That's how hard synthetic division is. Then we have long division. Of course, kids don't like long division, but some do. You'll actually see your kids who are better with math switch over to long division. They just like it better. And it makes more sense because the word synthetic means fake. I'm going to insert 0x cubed here because it was missing the x cubed piece. Whether I need it or not, I don't know. We'll find out. I don't know, I don't remember what I was thinking when I made this problem up. All right, so I'm going to turn x squared into 2x to the 4th by using a 2x squared. I'm going to invoke the distributive property. That would be 2x to the 4th plus 4x cubed minus 2x squared. Kind of like the way this worked out. I'm going to take away. There will be no x to the 4th. There is going to be a negative 4x cubed. Here we have a negative, take away a negative, that's adding, so I'm going to have to bring down my x. I probably need it. I probably got to bring down the -4 too. I don't know, we'll see. All right, now I'm turning x squared into negative 4x cubed, which means I'm going to need a -4. Yeah, I need to bring this down. So I'll have negative 4x cubed minus 8x plus 4. Right before I subtract, those are gone. Oh, I missed something. That's supposed to be an x, isn't it? Let me redo that line there. Sorry about that. I think I said negative 4x, but I wrote -4. I need the negative 4x. So negative 4x cubed minus 8x squared plus 4x. All right, here we go. Right before I subtract, there is technically no x squareds here. So 0 minus a -8 is 8. X minus positive 4x is -3x. And now I can finally bring down that -4. And I'm moving forward. This time, x squared into 8x squared. I need an 8. 8x squared plus 16x minus 8. Now I have a -3 minus 16, which is -19x. I have -4 minus a -8, which is +4, and this is my remainder. So, plus a -19 pieces of x plus 4, sitting pretty over x squared plus 2x minus 1. Notice how it always talks about remainder over divisor. Here's your quotient, remainder over divisor. And that's where I need to stop because classes start in a few minutes. Unless I have enough time to do this one. I do have enough time to do number 8. So this was pretty simple. It's the factors of the back, which is that guy, over the factors of the front. So the back is a 4. Ignore the sign. The front is a 9. So it's going to be 4 is going to be plus or minus 1, plus or minus 2, plus or minus 4. 9 is going to be plus or minus 1, plus or minus 3, and plus or minus 9. And then I just do the division. I'll take all 3 pieces and divide by 1. So my full list is going to be plus or minus 1, comma, plus or minus 2, plus or minus 4. And now I'm going to move on to the 3. Plus or minus a third, plus or minus 2/3, plus or minus 2/9. And now we move on to the 9. Plus or minus 1/9, plus or minus 2/9, and finally plus or minus 4/9. That's a good stopping point. So maybe during my planning period I can finish the rest of this.